Hello everybody, welcome to Olga channel. Today I want to give insight or more insight into the multiplication of matrices. I've realized that most students are finding it difficult to understand this concept or grasp this concept firmly. So I just want to take this opportunity to share an easy way or ways to really understand the multiplication of matrices, because like multiplication of matrices is the basics, is the basics in matrices, or is the basic part of the topic matrices. So without wasting much time, I'll dive into what the multiplication of matrices. So first of all, what is a matrix? A matrix is just an array of numbers. That's group of numbers. And then an example is if I write something like this, this is a matrix because it contains what different numbers at the same time. So to make it complete, we add the square brackets to make it a complete matrix. So after that, you have to ask yourself, so what does this mean? So every matrix has dimensions. When we talk about dimensions, we mean it has columns and then rows. So many students get confused with what a row is or what a column is. So when we talk about rows, rows are the horizontal part of what a matrix. We talk about columns, we're talking about the vertical part of matrix. So we know that if, okay, to make it easy to understand this, you see in the spelling of columns, you know that we have L in the spelling of the column. So to remember, just know that the L is vertical. So column represent the vertical aspect of the matrix. That's from top to down, from top to down, from top to down. Talk about rows. Rows is the horizontal part, that's from left to right, from left to right. I hope you understand this part. That's every matrix has both rows and then columns for the dimensions. And when you are writing the dimension of the matrix, we always begin with the row before the column. Don't begin with column before the row. Know that C comes before R, but you know that in the spelling of matrix, let me spell matrix here. The spelling of matrices, can see that the R, that's this, the R comes before the C. So if not for anything, you don't remember the dimensions of the matrix, just know that in the spelling of a matrix, the rows come before the columns. So it's the dimensions will be rows and column. So with this example, let's first count the number of rows we have. We said rows, the horizontal aspect. So we have 1, 2, means we have 2 rows. So when you are writing it, the rows will always come first. So you write 2 times. Then you count the number of columns. The number of columns is from up to down, that's the vertical, that's 1, 2, 3, and to be 3. So this would be a 2 by 3 matrix. That has 2 rows and then 3 columns. Then after understanding this, we have different ways of writing matrix. You can have 2 by 1 matrix like this. Let's say 1, 2. This can also be a matrix. Why? Because it contains numbers in an array form. And we said that the matrix has rows and columns. So this is the row, that's first row, and then second row. It should be that, it means that's what, 2 rows. The column is just only one vertical aspect. So it will be 2 times 1 matrix. Hope you understand. Can also have a matrix in this form. Say 1, 3. So this is also a matrix because it contains an array of numbers, and we can count the number of rows. Now we said the rows are horizontal part. When you count, it's only one horizontal part, so it means that's only one row times. So the column is the vertical part, so it has 1, 2, 3 columns. So it's a 1 by 3 matrix. Hope you understand. Okay, so now moving on to the multiplication of matrices. Before, let me say multiply, that's when we have, let's say, matrix A, and then matrix A, and then matrix B, then multiplying it is what we term as the multiplication of matrices. So let's say that, let me use a new screen. So let's say that we have matrix A, and always remember that the matrices are always labeled with capital letters, not small letters. So let's say we have matrix A is equal to, let's say, let's say that this is, sorry for my curly brackets, looks weird, but it's okay. So let's say this is for matrix A, or let me even stop the curly brackets, but always remember there's supposed to be a curly bracket. And then we have our B. Let's say we have 2, 7, and 4, 5. So let's say we have these two matrices, and we are asked to find AB. That's multiply matrix A and then matrix B. The first thing you have to know, you have to remind yourself is, ask yourself how many, or what's the dimensions for each matrix. So for matrix A, it has how many rows? We have 2 rows. So it has 2 rows. And then how many columns? We have 2 columns. So this is for matrix A. Then look at matrix B. Matrix B2 has how many rows? It has 2 rows and then 2 columns. Then you check what is the number of columns in the first matrix, and then what is the number of rows in the second matrix. If the figure you get are equal, then the multiplication can take place. However, if it's not possible, or let's say the number of columns of the first matrix that you are asked in the question is greater than the number of matrices in the second, or the opposite, then it is impossible to do the multiplication. Hope you understand. So for A and B, we can attest to the fact that the number of columns in A, which is 2, is the same as the number of rows in B, which is 2. So it means that the multiplication can hold. Then whenever we are multiplying, let's say 2 matrices, and if they satisfy this condition, then you know that the result or the resultant should contain the what? The dimensions, like the leftover of A and the leftover of B. So the leftover here of A is what? 2, and that's for the row of A. So the resultant matrix will have 2 columns, and then the remaining of B is also 2, which is its column. Then it means that the resultant matrix is also have 2 columns. I hope you understand that. So Then when we start the multiplication, so let's represent the figures of the resultant equation by letters. So let's say now we know that the resultant equation will have dimensions of what? 2 by 2, that's 2 rows and 2 columns. So let's say that's A, B, C, and then D. So now from here we can see that that's 2 rows and then 2 columns. So now how do we find for A? So when you look at the numbers in A and B, we're asked to find the A using the numbers in A and B. And we know that the position of A is, look, so this is the first row, right? So A is in the first row. This is in the first column, right? So A is in the first row, first column. B is in the first row, second column. C is in the second row, second column. D is in the second row, second row, second column. Sorry, C is in the second row, first column, and D is in the second row, second column. So here, now you have to find for A, that's first row, what? First column. So you pick the first row of the first matrix, that's 1 and then 0, and you pick the what? The first column of the second matrix, which is what? 2 and then 4. Because and that would give us the position of this A, right? So now how do we find the A? You say the first to first, the second to second. So you multiply number by the first row number by the first column number, the second row number by the second column number. So here we get 1 times 2 will give us 2 plus 0 times 4, which is a 0, giving us 2. So that now this 2, this 2 has become the what? The figure for A here. So now we've gotten A's figure, which is 2. We use the same procedure for B. B is in the which position? The first row, the second column. So we pick the first row and then we pick the second column, which is 7, 7, and then 5. Then we do the same. So 1 times 7 give us 7, plus 0 times 5, which is a 0. So when you add, the answer will give us a 7. So it means B here is what? 7. We do the same for C. C is in the second row, first column. So we pick the second row, which is what? 2 and then 3. Then we pick the first column, which is 2 and then 4. Then we do the same operations on it. So 2 times 2 will give us a 4, plus 3 times 4 will give us a 12. And the result is what? The result is a 16. So now it means that C is 16. Now we do same for D, which is what? The second row, second column. So you pick the second row, which is 2 and then 3, and then you pick the second column, which is what? 7 and 5. So now do the same operation. 2 times 7 give us a 14. 3 plus 3 times 5 will give us what? A 15. So now 15 plus 40 will give us what? A 29. So now D is what? 29. Sorry, I'm using paint, so it's kind of funny. So now this will be our resultant and our resultant matches. See that is not difficult. So one, satisfying the condition that the number of columns of the first matrix should be equal to the number of rows of the second matrix. That's the first condition. And then to know the dimensions of the second condition, we take the leftover of the first matrix, which will be the row, times the leftover of the second matrix, which will be its column. That will give you an insight into how the matrix would look like. So that's when you get um this unknowns. That's we know that it's a 2 by 2. So therefore it's have unknowns like A, B, C, D. Then to get the answer, this position of A is what? First row, first column. So you pick the first row and then the first column. Then you perform the operations 1 times 2, we are multiplying. Then you add the second one, 0 times 4. And the answer will give you the A. Do same for all, and then you get your answer. See, that's not difficult. So one caution that I want to raise here is that though we know based in our basics that A times B is the same as B times A, but in matrix, A times B does not necessarily mean that B times A be the same. Not in all cases. In this case, let's say we are asked to find B A. So the dimensions of B is what? 2 times 2. And the dimensions of A is also 2 times 2, right? So this is the column of B and the column of A. See, so this is what we'll be matching to see if we can multiply. And we see that they are the same, so it means we can multiply. So here, the B times A works. But in cases, let's say B, let's say A is a 3 by 3 matrix. 3 by 3 matrix. And then B is a 2 by 3 matrix, right? So let's make this a 2 by 3 matrix. So let's say AB is possible because the column of A is the same. The AB is not possible because the column of A is not the same as the row of B, right? So the multiplication of A and B will not be possible. So let's look at B and A. So now here B comes first. So the column of B is 3 and the row of A is 2. See that? So this situation or this scenario cannot what? This scenario too cannot hold. Please you get it? So it's not in all cases that we can multiply. So let's say that A was 3. Sorry, and my board is clustered. So let's say A was 3. So let me use a new board. So let's say A is what? A 3 by 2 matrix. And let's say B is a 2 by 3 matrix. So when we are asked to multiply A and then B, we have to first check if the condition satisfies that the column of A should be equal to the number of columns of B. So here, this is the column of A, which is 2. Should be equal to the number of rows of what? B. And B is also 2, which means that it can work, right? Which means that it can what? It can work. So let's see for B and then A. So now here B becomes the first matrix. So the number of columns of B, which is 3, should be equal to the number of rows of A, which is A. Can also work. So let's say that A is a 2 by 2 matrix. They are working to it's a 2, sorry. Let's say that A is a 2 by 2 matrix, and then B is a 2 by 3 matrix. So when we say AB, let's see if it can work. The number of columns of A is the same as the number of rows of B, so it means it can work. What about BA? So the number of columns of B is 3, the number of rows of A is 2, which means this cannot hold. You get it? So in every situation or in every question that you are asked, you have to first check the condition. If the number of columns of what the first matrix same as the number of rows of the second, before you multiply, don't just assume that because it's multiplication, AB will be equal to BA. But this is a matrix and not just one number that we are working. I hope you get it. So thank you for listening to the video. I hope this really helped you, and I entreat you to leave in the comment section any question that you have so far regarding multiplication of matrices, and then I'll attend to you. It's good to help one another so that we can all excel in our academics. God bless you. Have a nice day. Also, please don't forget to share, subscribe, and also like the video. Thank you. Bye bye.